Hello. So this video picks up where the first one left off. We had, if you'll recall, created this scatter plot, and it solved some problems, getting to this, with filtering out the question marks and the zeros and stuff like that. And now we got the scatter plot of KW versus temperature, and maybe I ought to just annotate this a little bit. So I'm going to get into my chart. I'm going to do a Davidism. I'm going to switch it to my favorite font, and so there, did that. Maybe make the font a little bigger so you can see it, and label the axes. So I want to design, I want to add a chart element, I want to add an axis title to the primary horizontal axis, so that's outdoor temperature. Degrees Fahrenheit. And then I want to add axis title also to the vertical axis. And so this is KW. So now I got my chart labeled. I don't really need this title since it's pretty obvious what it is. It's KW versus outdoor air temperature. So I'm just going to take it out, give my chart a little bigger. Okay, so sort of where I'm heading here is, you see these patterns, and it probably has occurred to you, well, if we could use, just like we filtered the question marks out, if we could make a filter that filtered out, different times, different days of the week, that kind of stuff, we may be able to identify what's causing these patterns. For instance, if we filtered out all the hours between, just to take a stab at, I guess, if we filtered out all the hours between 7 in the morning and 5 in the evening, we may see this cloud get very light or disappear, which would basically say, oh, that's the energy associated with things that are going on in the building, and this happens to be a hotel, so like meeting rooms being used and stuff like that, and this is the base load. So that's one of the things we'd like to be able to do, and that's one of the powerful things about, you get these scatter plots, you can start using filters to identify what's triggering the patterns. And so let's go ahead and make a column for the hour and the date and the time and things like that. And so Excel has some built-in features called date value and time value, where you can have it look at a text string and tell you what the date and time value is associated with that. And what that means is, and there's other blog posts where I talk about that, but just real quick, what that means is Excel works with dates and times. When you see a date and time in Excel, it's actually just a formatted number. It's a serial number that started at 0 on January 1st of 1900 in the Windows operating system. I think it's 1904 in the Mac system. But anyway, every day that number gets incremented by 1. So for instance, if I go in this cell and type equals now, which is just an expression to return the current date and time, I see a thing that says it's September 4th, 2015 at 8:20. If I copy that and paste the value in the cell down here, see I actually have a number, 42,251.34745. What that really means, it's 42,251 days since January 1st, 1900. Tomorrow it'll be 42,251. The 0.34745 part is it's 8 hours and 20 minutes into the day. In other words, if I take and make a little formula that's basically equal to 8 out of 24 hours, that's 0.3333, and then if I add 20 minutes to that, okay, and 20 minutes is in the context of an integer of 1 equaling a day. So 20 divided by, I think this will work, 24 times 60. Oops, I forgot to make it a formula. And so the time changed, make it 21 minutes. And so if I add, it just changed again, make it 22 minutes. I could lock the time down, but if I add that plus that, that's where that number comes from right there. I'm just rounded off to different number of decimal places. So the point is, Excel's working with date and times as a serial number, and so we actually need to break that down to be able to get the hours and minutes and days and stuff broken out of this state here. So let's just go ahead. I'm just going to clear this out now. Served its purpose. Let's just go ahead and use some of the Excel functions to convert this, to get us something we can work with. So I'm going to say equals date value, which basically converts a date in the form of text to a number that represents the date in Excel. So I'm going to say date value. So I double clicked on that, and so now it's letting me fill in the parameters it needs. And easy way to do that so you don't get it wrong is just go up and click on the function symbol, and it opens up a little box that sort of coaches you through. And so I want to use this date. Okay, so I want the date value from that plus, oops, so I say okay. Then I want to also have the time, so I want plus the time value. For that, oops, I messed up there. Plus time value. There we go. Forgot to double click. Go to there, and then tell it, yeah, I'd like to look at that. And I say good. So I should get a serial number that, now looky there, I got a mistake. It says I don't know how to evaluate this. And actually I did that on purpose. And full disclosure, the data set Nick gave me, this was in a different format. I just put these in so I could illustrate this concept. Excel's date value and time value functions, they recognize sort of standard ways of doing date and time. For instance, I'm just going to copy this up here so I don't forget it. Paste values. If I, instead of doing 2015-01-01-00, if I did 1-1/15, with a time, 00, common 00. I was thinking this would, date value plus time value. I was thinking that formula would work with that, but because I thought it would recognize, because this is formatted as text. No, it's formatted as just a date. I don't want to get all hung up on this, but the point is we need to go ahead and make ourselves, we need to take this apart, this text string apart, and then rebuild it into a string that we can then use as an Excel date and time value. And so that's what I really want to show you next. And I don't want to get all hung up on why certain things didn't happen that I thought would happen. So basically what we really need to do is extract the year, the day, the month, and the hour out of this text string, and then put them back together again in a text string that Excel would recognize. So let's make a column for each of these things. Year, and we'll need these columns anyway to do the filters. Year, month, day, and hour. So there, I have a column for each of those metrics. I'm doing a Davidism again here. I'm going to center it, and I'm going to put everything on the spreadsheet towards the top. Okay, so now basically to get the year, I want to somehow extract 2015, and so I'm going to say there's a function call in Excel called left, and basically what it'll do is it'll extract from a text string however many characters you tell it, starting on the left. So the text string I want to use is this, and I want to extract the first 1, 2, 3, the first 4 characters. So I'm going to say comma 4, and there's 2015. Now I want to get the month, so that's that number right there. There's another function call called mid, so equals mid, and what this one does is it extracts text from the middle of a text string, and you tell it how far in to start and how many characters. So I want to, from this text string, I want to come in 1, 2, 3, 4, 5, 6 characters and extract 2. So basically I want to start in at 6 characters and I want to extract 2. So there's the month, and I do the same thing to get the day, except I want to come in 1, 2, 3, 4, 5, 6, 7, 8. I want to come in 9 characters, and I want to get 2 of them. And then the hour, I could use the mid thing and count over, but there's also a function call called right, which works just like left but from the right. So we're going to say equals right. Pick the text string. Oops, I forgot to say equals, or I forgot the parentheses. Equals right, parentheses, this text string, and I want 2 there. Okay, so there's the hour. So now I've got that stuff all broken out. So now let's build a text string that Excel would recognize, that we can then use to, for instance, come up with the day of the week, because that might be helpful. You know, Monday, Tuesday, Wednesday, Thursday, Friday in a hotel may have different energy use patterns than Saturday and Sunday. In fact, Saturday and Sunday could be different. So it'd be nice to be able to extract the day of the week, but to be able to extract the day of the week, we need the number to be an Excel recognized serial number for date and time. I'm just going to clear that out. And so let's go ahead and put this back together. So the first thing I need to do is make a text string. So this is an Excel recognized text string. So basically I'm going to put it in the month, day, year, hour, minute, AM, PM format. So basically I'm going to use the little formula that lets you just string text together. So I'm going to say equals the month, and then I'm going to say ampersand, and then I'm going to put a quote in, and I'm going to put the backslash. So the quote lets me insert that character. So there's the month, ampersand, the date, the day, quote, backslash, quote, oops, backslash, and then ampersand. I want to add now the year, and then I forgot my ampersand here. Okay, and now I want to put in a space, so I put a quote, space, quote, ampersand, the hour. And we don't have minutes, but I think I need the minute thing for Excel to work, so I'm going to put a ampersand, quote, colon, quote, and I'm just going to put quote, colon. I'm going to just put my own zeros in, 0, 0. In other words, the data we have is on the hour, basically. So if I've done that right, let's see what happens here. Yeah, so now I get a little string that looks like a month, date, and time. But what the difference is if I can now take this text string and use that date value and time value to create that Excel recognized date and time. So let's put a column in here called Excel date and time value. Oops. And so I'm going to try the date value thing. So I'm going to say equals date value of this plus time value of this. And you'll notice now I get a serial number, and it actually has more decimal places than that. Oh, no, it's at midnight, so it would be 0000. So now if I make this column equals to that column, just copies it over there, but I'm going to format it to be a date. So now I should have labeled this date and time value. So let's a little Davidism stuff here. Get the column widths, center stuff. Okay, but now for this column, I'm going to apply a formatting. And I'd like to know the day of the week, so I'm going to say format cells. And I'm going to use a custom formatting. You have to work with this a little bit. I do this a lot, so I know the symbols that I want to use. The point is, you can easily do this. I just wanted to illustrate the concept. If you go out and go on the internet and type Excel date code, you'll get a whole table that has the stuff I'm going to use. But like if I type in day space year, that'll give me so the day thing will write the name of the day out in total. If I put day 3Ds, it would be like for Monday it'd be MON. 4 Ds gives me Monday. YYYY, 4 Ys gives me the year 2015 / month gives me a 2-character month number. Day gives me a 2-character day number. Space hour colon minute space, and then I'm going to put AM / PM because my brain works easier with AM PM things versus the military time thing. So that's the format I want to apply. And so now you see that it basically has formatted this number to say Thursday, January 1st, 2015 at 12 a.m. Okay, so now all I have to do is type that into the other 5,000 rows of the spreadsheet, and then I can move forward. And clearly I don't want to have to type it into 20,000 rows in the spreadsheet. In fact, I'm going to close this formatting thing, and I stretched my graph out more than I wanted it, so I'm going to put it back like this. All I need to do is I need to copy those cells, so Control C, and then I'm going to go to this column here. If I just did Control Shift down arrow off of these columns, I'd go all the way to the bottom of the spreadsheet because the Control Shift down arrow thing looks for the last value in a column. So I've got those cells copied. I'm going to go over to here. I'm going to go Control down arrow to find the bottom. I'm going to arrow over, and now I'm going to Shift arrow to get all the cells I want to paste into. Now I'm going to hold Control and Shift and up arrow. Oh, I need to go over one more column. Oops, I'm going to start over again because it's going to take me longer to. So I do Control down arrow, find the bottom, and now Shift over to highlight all the columns I want to paste into. Control Shift up arrow takes me to the top. Let go of Control down arrow 1 unhighlights that first row, and then Control V or paste whatever you want to do, right click, paste, pastes those formulas into all those cells. So now I've created that Excel date and time for every row in my spreadsheet, which is what I wanted to do. Okay, so now we can start filtering things. And in fact, we didn't need this to filter out by hour or stuff like that, but what I wanted to be able to do was filter by day of week. So let's add a column here for the day of the week. In other words, Monday, Tuesday, Wednesday, Thursday, Friday. And there's an Excel function call that lets you do that. So that you say equals day, or I'm sorry, week, I think it is. Weekday equal week. Yeah, weekday. So weekday, the serial number is in here. And then basically the return type tells it, is 1 going to be Sunday with Saturday as a 7, or is 1 going to be Monday with Sunday as 7, or is Monday going to be 0 and Sunday going to be 6. So I'm going to use 1 for Sunday and Saturday is 7. So I want to put a 1 in here. In other words, by putting 1 here, I'm saying make Sundays 1, Mondays 2, Wednesdays 3. So that'll give me a number in this column that corresponds to the day of the week. So I'm going to say OK. So now I got 5. That makes sense because it's Thursday. 0, 1, 2, 3, 4, 5. Okay. So now let's copy that to all those cells. So Control C, come over here, Control down arrow, right arrow over, Control Shift up arrow, captures everything, let go of Control, come down 1, and then paste. I'm used to doing Control V, but I also could jump over there and say paste, and this time pick the formula. So now I've got a day of the week in here. So now let's just start playing with these filters and watch what happens to this data pattern. So for instance, I'm going to apply a filter to the entire shoot and match here. So I'm going to highlight that row and I'm going to go to the data tab and I'm going to hit the filter symbol. And now notice I've got a drop down on all of those columns. So let's filter for the day of the week. Let's filter out Saturdays and Sundays and see if that changes anything. And it does. You'll notice this pattern got lighter and it narrowed down. And so what that's saying is there is some difference in how the facility uses energy on a Saturday or a Sunday versus a day of the week. Let's look at it a different way. Let's put Saturday and Sunday back and say, we suspect this is the base load. In other words, certain hours of the day this cloud will disappear. If that's true, if this is something that only happens to carry the building when like the meeting rooms aren't in use and the shops are shut down and stuff, by playing with the hour of the day, we may be able to make this cloud go away. So let's filter out the hours. I'm going to take a guess that maybe, the facility doesn't have much going on at midnight or 1 or 2 or 3 or 4 or 5. Or maybe 6 they start running the air handling systems to cool the meeting rooms down and get them ready for the day or warm them up in the winter. And that they might have meetings going until 6 in the evening. And then after that, most of the meeting rooms are not in use. Now, there could be the occasional event, but generally speaking, I'm going to filter out those hours. That's just a totally sort of scientific wild-ass guess. I'm fishing a little bit, but I want to see what happens if I filter those hours out. So I've basically now said, well, let's just look at the pattern from 6 in the morning until 6 in the evening. See what happens. Now when I do that, this base load thing almost disappeared. So I'm going to do it backwards. I'm going to get rid of the hours. So I'm going to select all. And I'm going to get rid of the hours where I think the building's in use and see if I can make this cloud go away. So I'm going to get rid of 6, 7, 8. Because it clearly had an impact. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So now I've basically said, let's look at what's happening during the hours when we're guessing the building might just be, guests in their guest rooms, restaurants, stuff like that. Say okay. Okay, now two things happen there. I forgot these axes are auto scaling right now, so let's fix that so that a pattern change is a true pattern change in the context of what was there before. So let's do two things. Let's take this filter back out just so we start, so you can contrast things. And then I'm going to lock this axis down to 0 to 450. So I'm going to hit the Format Axis button. I'm going to go out here, Axis Options, and right now it's auto. If I type a number in here, I'm going to keep 0 to 450, but notice when I typed a number, now I have a reset button. It's going to lock this axis down instead of auto range it. 0 to 450 on that one, and let's make this one, we could narrow this one down a little bit, make it 10 to 110. So let's make it 10 to 110. Okay, now I've got reset, which means I've turned off the auto scaling. So now let's go back again and filter those hours out so that when the pattern shifts on you here, it really is a pattern shift that you can compare to the pattern that was there. And I'm going to move this over a little bit so it's not in the rows I'm trying to filter, so you can see what happens without that box being over top of it. And while I'm at it, I'm going to move this filter, this column over on this side. I'm going to copy it, so I'm going to say Control C, and then I'm going to say Control X because I'm going to delete it there. And then I'm going to come over here and I'm going to say Insert the cut cells, and it puts that row over there for me. And the only reason I did that was so that when I click on these filters, they aren't sitting on top of this graph, so you'll be able to watch the graph as I play with the filters. That's the only reason I did that. Okay, so let's go ahead now and try that filter again so you can watch the pattern shift without the scale changing. So I'm going to filter out all the hours that I think the facility might be, sort of up and running. You might say meeting rooms, ballrooms, things like that. And again, this is just an arbitrary guess I'm making, having been around hotels and just, sort of knowing how the facilities tend to be used. So I'm going to turn off all those hours and watch what happens when I say OK. So interestingly enough, most of that cloud up there disappeared. So it's sort of saying, hey, your hypothesis may be pretty good, but there's something going on some hours that's keeping this cloud here. What I'm trying to do is I'd like to get this to where I just have a cloud here, and I'll show you why in a minute. So let's just play with this some more. Let's I don't know, let's add 6 and 7. Maybe they don't start the meeting rooms quite as early. Or let's add 6. Let's just do it an hour at a time. Okay, that affected it the wrong way. So let's take 6 back out. Oops, I want hours, not day a week. Actually, let's filter out Saturdays and Sundays now. Let's take Saturday and Sunday out and see what that does just for the heck of it. It didn't change. It changed both clouds a little bit. So let's put them back, because what I'm really trying to do is see if I can identify when the base load hours are. What hours does the facility have a consistent pattern no matter what's going on. So let's filter out a few more hours of the day, or let's add some, or I don't know, let's see. I really am fishing. I'm gonna say maybe they don't shut the meeting rooms, run the meeting rooms as long as I'm thinking. Okay, well that went the wrong way. So let's go the other way. Let's add a few hours. Or, I'm sorry, let's add those hours back in and take these hours back out. Maybe the meeting rooms run a little later than we think. Okay, that's making some progress. Okay, they start a little earlier, maybe. Okay, so you see we're making an impact here by how we switch these hours off. Shut off 3. There's hardly anything left. Okay, now I seem to have a pattern, and so what this is basically the base load consumption pattern for this facility. And so I could actually calculate how much energy the facility uses as base load if I could come up with the equation for that data set. Which, there's mathematical ways to do that you may or may not have learned, at some point in your career. But Excel makes that pretty easy. If I right click on this data series and I say add a trend line, basically Excel starts out and saying, well, there's what a straight line would look like. And I'm going to add 2 things. I'm going to tell it to display the equation for the line on the chart and to display the thing called the R-squared value. Okay, so I'm going to stick that up here where you can see it better. The R-squared value is basically a statement of how well the data fits that line. If R-squared was 1, every single point in my data set would be right on the line. So the closer R-squared is to 1, the better off we are. And so you think initially, well, that's not a very good R-squared at all. And we may be able to do better, but the thing to remember for a building is we're looking at kW as a function of outdoor air temperature. And it's actually a function of a bunch of other things probably besides outdoor air temperature, like, the occupancy, for instance. That's probably a big driver in a hotel. So there's other things affecting this data besides the outdoor air temperature, which means the scatter is going to be there. And so another way of saying this is in the medical community, when they're looking at how a human body reacts to things and they're plotting like sweat production as a function of outdoor air temperature, they'd consider R-squareds in the 4.4, 0.5, 0.6 to actually be really good because there's so many other things that could, for instance, affect the human body and cause you to sweat, like you're anxious, you're nervous, it's humid, it's not just hot, it's humid. So the point is, the more things that can interact with a parameter, the more scatter you're going to have. And so this isn't an awful R-squared, but let's see what would happen if instead of using a straight line, if we used a polynomial, in other words, a curve. Okay, so now if I use a curve, I get an R-squared of 0.85 with a second order polynomial instead of a second order polynomial. Polynomial means there's x and there's x squared. Let's try a third order polynomial and see if that gives us an any better fit. So over here I'm going to say 3, and it improved it a little bit, but not much. It's like 0.854 versus 0.855, and it makes the math much harder. So I'm just going to stick with a second order polynomial as a curve fit. And so what that means is y is kW, x is outdoor air temperature. So this equation saying I can reasonably predict the baseload energy consumption as a function of outdoor air temperature. If I plug this equation in and basically look at outdoor air temperature, substitute it for x, I can calculate about what the kW consumption will be. That's a very, very powerful thing for us when we're trying to understand how buildings use energy. Because if we can do an analysis like this and get a sense of what's driving a pattern, what this means is, and this isn't a year's worth of data, it's about half a year's worth of data, but with reasonable confidence I could project for the entire year using this equation what the baseload energy consumption of that building is. And so I'm going to stop here to manage the recording length and file sizes and stuff, and then we'll come back and pick up and look at this a little further in a minute.